Hi there. Today we're going to look at what it means to change the base of a logarithm. But first I'd like to take a look at this problem. If we would like to solve for x, we have a base of an a. We can log base a both sides because the base will cancel the exponent on the left. Then you have this equation, x equals log base a of b. And that really just comes back to the fundamental idea of what is a logarithm. It is the anti-base. It undoes the base portion of the exponent. Let's take a look at that same problem again. What happens if we don't use base a? What happens if we use any other base? Let's say log base c. Well, at first glance, that's not going to cancel the base of that exponential. But we do know log base anything with an exponent is the same thing as multiplying that exponent out in front. So we're going to use that little trick to say that this side of the equation is going to be x times log base c of a, and it will equal on this side log base c of b. We're going to divide both sides by log base c of a to leave x alone on the left. Well, what does that show us? Right now, we know that x equals this. We also know that x equals this. So that means that those two things need to be the same expression. So we have a new formula that says log base a of b will equal log base c of b divided by log base c of a. Keep in mind that the c that we chose, it's an arbitrary thing. We can use base 10, we can use base e, we could use base 6, we could use base pi if we want to. Let's take a look at just what it looks like procedurally to use this formula here. If we would like to rewrite this as any other log base besides 3, let's say we have base 10 tables, or we have that lovely button in the calculator that is log base 10. We can convert this our a is 3, our b is 7. We can choose, again, whatever log base we want. I'm going to choose log base 10. 7 is the argument of the original log. That's the argument in the numerator. 3 is the base of the original log. That's the argument in the denominator. So this is the same expression as this. And if you have an old calculator that can't do any other bases besides 10 and e, this is how you would type that in. Similarly, if we wanted to go the other way with this, and we want to condense this into one logarithm, we can do that as well. We know we have matching logs here. There's both base 6's, and as long as those bases are the same, we can put the numerator argument as the argument of the big log and the denominator argument as the base of the big log. So this thing would be log base 5 of 8. Looking at that with a little bit more interesting of a problem, we can say that this is log base 2 of 32 over log base 2 of 4. Why did I choose 4? Because that's a common base between 4 and 32. Log base 2 of 32 is asking how many 2's multiplied to get to 32, and the answer is 5 of them, over how many 2's multiplied to be 4, and the answer is 2 of them. So log base 4 of 32 is 5 halves, or 2.5. That's a little introduction on change of base formula. It's a fairly simple formula. It doesn't make a whole lot of sense in the days where we have calculators that can do any log base, but it's still useful to know in terms of trying to get logs to have a common base across an entire equation to be able to compare some things. So, hope you learned a lot, and I'll see you later. Bye.